Hello, my dear students. Today we are uh, going to discuss about Module 5 related to the arches and cables. Under that, we are discussing about arches today, that is introduction part related to the arches. As we all know, modern engineering construction, arches plays a very vital role. And it is also observed that if you construct a arch across a opening, the opening span, if it is more, then definitely it is a good economical structure. So arches are more economical based on its span. If the span is more, then if you construct a arch, it is more economical. And this is related to the practical part, and even the aesthetic part of the arch structure is good. So it looks very beautiful if you construct a arch for a opening or for a bridge which is structurally made up of arch. Okay, that's just a brief introduction about arch, and we will see some of the technical topics related to the arches. We have two different method of classification of arches. Under that, one will be classification of arches based on the number of supports or number of hinged supports. So we have three different classification based on its supports, or we can say based on its hinges. Okay, we have three different classification. One among is 2-hinged arch, another one is hingeless arch or fixed arch, another one is 3-hinged arch. Okay, name itself indicates. See, this is an example for 2-hinged arch where we have 2 hinges at the bottom. Okay, that is called as 2-hinged arch. And another one, this is a fixed or hingeless arch where there is no hinges but we have a fixed support at the bottom. Whereas in 3-hinged arch we have 3 hinges, 1, 2 and 3, one at the top, 2 at the bottom. Okay, and basically here very important thing is 2-hinged arch and fixed arches are statically indeterminate structure. This structure cannot be determined by using 3 equilibrium conditions. We need additional equations to solve statically indeterminate structures. Those equations we call it as compatibility equations, that you know in the module 1 we discussed about compatibility equations. Whereas in a 3-hinged arch we have 3 hinges, so we can say this is a statically determinate structure. This can be solved by using 3 equilibrium conditions, that is summation of f of x equal to 0, summation of f of y equal to 0, moment at any point equal to 0. Based on the hinged supports we have 3 different classification. One is 2-hinged, hingeless arch or fixed arch, another one is 3-hinged arch. In your syllabus we are focusing mainly on the determinant structures, so we are worrying only about the one arch, that is 3-hinged arch. So even based on the shape also, arches are classified into two different types. One is circular arch, name itself indicate it is in the circle form, or we can say it is like a semicircle, even it will have a radius also. So one is a circular arch, another one is a parabolic arch. So both we have in the syllabus, that is circular as well as parabolic arch, that we will discuss in future. Okay, in addition to that, today we will see some of the important parameters uh, needed for analysis of a 3-hinged parabolic arch. Okay, first we are considering only parabolic arch here. So very important thing, see it have 3 hinges, 2 at the bottom, 1 at the crown, or we can say this one another name, we can say it as a apex point. Okay, see A, B are the two supports, these are the hinges at the bottom, another one is apex point, or we can say crown, so it is topmost point for the arch. Okay, and very important thing here is length or we can say span of this one, span of the arch will be indicated by L, and small h here indicates the rise of the arch, or we can say in another word it is height of the arch, where y is a vertical distance with respect to the section xx that it is shown in the figure, and small x is a distance with respect to any one of the support, either it may be with respect to left or it may be with respect to right. So small x will gives the horizontal distance with respect to any point in the portion A to C. Okay, where L is a length or span, or we can say distance between A to B, and h is a rise. That what I shown in this figure. It is very important, please concentrate on it. So where y is a vertical distance with respect to any reference axis, here I am considering xx, it is derived that y will be equal to 4 times of rise multiplied by horizontal distance x divided by total span. It is square of the total span whole multiplied by L minus x, where x is a horizontal distance with respect to the reference axis xx, L is a total span, small h is a rise. That what it is shown. So this is the equation you need to remember in order to find out the slope at a in order to find out the rise at a given particular point, so wherever it may be in the arches. So you should remember this one. And if you partially differentiate this equation with respect to x, you will get another one equation that is called a slope equation. So if you partially it is differentiated with respect to x, not partially. Dy by dx, that will be equal to, we are considering this one as slope tan theta, that will be equal to, this is the derivative of that. So that is called a slope equation, and this one we call it as a rise equation for parabolic arch. And very important thing, you have another two important topics which are related to the normal thrust as well as radial shear. So normal thrust, normally it will be acting along its longitudinal length, or we can say longitudinal axis. So it is represented by n dot t, that will be equal to h cos theta plus v sin theta, where h is a horizontal thrust and v is a shear force at a section, that I will explain while solving the problems, how to calculate h as well as how to calculate v, even how to calculate theta. And another one we have, that is with respect to radial shear. It is once again the shear force created due to the radius of the arch acting radially. So that is also we have one expression. It is indicated by r dot s, that will be equal to h sin theta minus v cos theta. These are the four equations you have to remember in order to solve the problems. One is a rise equation, another one is slope equation, another one is normal thrust, radial shear. So these are the introduction part of the arches. In the next video I will post about problems related to the 3-hinged parabolic arch. Thank you.